Now, we will deal with certain numericals and application level questions. So, just write down the question. The potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 ampere from the source. So, what is given? A potential difference between the electric heater is 60 volt. So, volt V is given as 60 volt. Voltage is given as 60 volt. When it draws a current of 4 ampere. Here the current is 4 ampere. The question is, what current will the heater draw if the potential difference is increased to 120 volts? So here we are using another source where the voltage is 120 volt. Children, you have to think, when we change an instrument from one circuit to another, what is the property of that instrument or the device that will not change? So that will be, of course, the resistance of the conductor. Because when it is made, the resistance is set with its own coil of wire or its own things used inside it. So whenever we have to note the point that whenever we change an electrical device from one circuit to another, nobody can change its resistance offered by the instrument. So when the previous source, if there is V and there is a current I, we can calculate R here, right? So that will be 60 V by I. So what is it? It will be 60 by 4. That's a very important point that we are dealing with. So that answer will become 15 ohm, you know. Because 60 divided by 4, you will get it as 15. And this resistance is, or this device is fitted with another voltage source. So you can use this resistance here, where we can write that with another voltage source R is equal to 15 ohm. Then what is the question given? What is the current drawn? So we know that I is equal to V by R. V is equal to IR, R is equal to V by I is equal to V by R. So what is your answer? 120 divided by 15. So what is 120 divided by 15? It will be 8 amps. So this is the question. So this is a typical question given to you. When a circuit is changed, a device will not change its resistance. So whatever resistance has calculated in the first circuit can be used in the second circuit unless we are changing the number of turns of the coil and that type of things. Let's deal with a hot question or an application level question. So there is an IV graph given here. IV graph given here of two metals, one is A, or two conductors, one is B. Which is having more resistance? That is the question. Which is having more resistance? So look, what is plotted on the y-axis? I. What is plotted on the x-axis? It is V. So we have discussed it in the previous class that when I is plotted on the y-axis, the slope of the graph will give 1 by R value. So greater the slope, lesser will be the resistance. So question is, which of these two metals A and B is having high resistance? So we are going to the analysis of the graph. Which of the graphs is having greater slope? We know what is the slope. The slope of A from the x-axis, the angle is less. The slope of B from the x-axis is more. So the slope of B from the x-axis, that where B is marked, is more. The slope is more. Slope is more means resistance is less. So we can write that the slope of A is lesser than slope of B. Can we write it like that? Because from the graph itself we can understand it. Slope of A is lesser than slope of B. But according to the concept, here the slope is inversely related to R. So what we can say? Resistance of A is greater than resistance of B. So which is having more resistance? A wire is having more resistance. Hope you have got it. Let us come with more numericals in the next classes.